Hello, and welcome to the Diet NPO podcast. My name is Zach, and I'll be your host. What's up, wonderful people? How's your Thursday going? I am finishing this week just squeezing in some of my at-home projects, my van work, some of my tutoring, before I go back to work at the hospital this Saturday, as I'm the one who's going to be on for my Saturday coverage this week. So if you sadly end up in the hospital, you may have to hear from me this Saturday, so why don't you go ahead and prevent that at all costs, just so we don't have to put any extra work together. I've been waking up in the morning, and when I should be definitely doing some reading, doing some extra work, I've actually been trying to catch up on some of my shows, such as the new Dahmer series that's on Netflix that I don't know if you've gotten a chance to see. Now, it's pretty odd seeing Michael Scott's nephew ending up as being a serial killer, so that's kind of shocking. But the actor Evan Peters has been doing a really great job, I think, as depicting this type of actor. And I knew that because I had been following kind of serial killer type things for a while. I really enjoy a lot of serial killer documentaries, true crime podcasts, and that's been since I was even kind of younger in my teens too, so it's kind of cool to see this. So, I think that with this new show, the big thing has been, of all of the things I've ever watched, this is easily the one that's made me the most uncomfortable. And that's actually saying something, as I've seen a lot of these different types of shows. What I am really glad is they're trying to highlight a lot of the victims instead of really the perpetrator in this case, which I think is a really good idea. It's making sure the victims are known, not just who the serial killer is in this case. Speaking of stories, who doesn't like a good patient story? I'll share a quickie from this past week, when I see my head and neck cancer patients, I tend to get a lot of good stories from them. Now, if you didn't know, head and neck cancer can be attributed to a lot of different lifestyle types of behaviors, some of which are smoking, drinking, chewing tobacco, but that drinking one is one that I think a lot of people forget about, and that's a really common one. Whenever I speak to one of my head and neck cancer patients, I'm always mentioning how much we want to abstain from alcohol during this time, so I really just recommend not drinking at all. This is mostly because when we shoot radiation at that neck area, that lining becomes so raw, so irritated, that pouring alcohol on it is kind of like pouring alcohol on an open wound. It does not feel too sweet. So let me tell you about one of my patients named Sam today, who really wanted to keep up with his habits. Sam was not going to let me saying to not drink stop him. Sam has a feeding tube, and so really, he wasn't going to be able to do much drinking in the first place. During our first visit, I divulged, hey, gotta avoid alcohol during this time. It's not going to make it feel good. It's not going to help out any of your healing process. But again, like I said, he was not going to let that stop him. At our recent follow-up visit, he decided to mention to me that he has continued to drink, but he's not drinking orally anymore. He is actually pouring beer down his feeding tube and using it like a beer pong. I know, seems ridiculous to think about. When I always think about that, I'm like, the only thing I want going through that feeding tube is going to be our formula and our water. I don't want to see anything else going through that tube. So kind of imagine someone just cracking a brew and just kind of pouring that down their feeding tube. Imagine that foam kind of going down. So it's kind of an interesting story. So I really recommended he stop doing that as soon as possible. But some patients will do anything just to make sure that they can keep up with some of their habits. But enough stories from me today. Let's all learn together and discuss some plant pigments that we might need to know for the RD exam. Let's learn a little bit about these different fruits and vegetables and the pigments that they will be attributed with. I like to start with my greens here and mention our chlorophyll type of foods. This is our green beans, our broccoli, some of our leafy greens that have chlorophyll in them. Remember, we learned about chlorophyll way back in our biology class when we talked about like photosynthesis. Remember that? It's a big throwaway. Now, you probably did the chlorophyll test, possibly in one of your food science type classes or in one of your kind of like labs. You could have done something like that. Chlorophyll reacts in a state of acid or base. So chlorophyll contains magnesium, and that is the component that is usually changing in a state of an acid or a base. Picture going all the way back to junior high or high school, whatever grade you were in, and picture when the lunch staff would put out those big pans of green beans, usually probably canned a lot of the time is what I always saw. Now, how did those green beans usually look at the end of the lunch period? Did they look very attractive? Did they look very appetizing? Well, no. A lot of times those green beans turn this kind of odd olive brown, gross color, and that is what's known as pheophytin. Pheophytin, that magnesium component of the chlorophyll, when the chlorophyll comes in contact with excessive heat or in terms of acid such as vinegar or lemon juice, that chlorophyll and that magnesium will change into what's known as pheophytin. This happens because of that excessive heat. And the thing that I always think about to remind myself about pheophytin is that pheophytin, think of it as fighting off that acid and fighting off that heat. So when a question will ask you about pheophytin, you just need to think about acid or heat in that olive brown kind of unattractive color there. Whereas we have another side of this, which is what's known as chlorophyllin. Now, chlorophyllin is what happens when these chlorophyll comes in contact with a base. So that chlorophyll is going to degrade to what's known as chlorophyllin. And chlorophyllin is actually this really bright, really vibrant green, almost kind of like an odd highlighter color, I like to think of it as. And when I think of chlorophyllin, I think of chlorophyllin as being this kind of guy that is all dressed up. And actually, I actually think about being dressed as a pimp, honestly, because they're wearing this bright, bright green suit, plenty of jewelry, and chlorophyllin is straight up chilling like a villain. So that's what I think of when I think of my base, and I think of my chlorophyllin in that case, is they're just chilling out, looking fly. Moving on to our carotenoids. This consists of our lycopenes, our xanthophylls, and our carotenes as the kind of those subclasses there. Lycopenes is what you should know as is the antioxidant that is present in a lot of our tomatoes. Xanthophylls is the yellow, such as in a yellow bell pepper. And carotene is what we think of as orange, or carotene as in carrots, right? Now, think of last week when I made my fall carrot soup. And think about you when you might cook carrots in the oven. When you expose those carrots to excessive heat, are they still orange after you've done that cooking process? Well, if you recall, maybe they'll brown a little bit, but guess what? Carotenoids stay the exact same color whether we're adding excessive heat, excessive base, or excessive acid. They will not change in any of those states. They are very, very stable in a state of heat or pH system. So that's one of the easier ones to remember just because we know that they're always going to be stable no matter what the circumstances are. Next one will be our flavonoids. Flavonoids are one of my favorites. Subclasses here you can think of as being like our anthoxanthins and our anthocyanins. Anthocyanthins, they have an X in the name. And so when I think of an anthoxanthin, I think X as being like lack of color. So I think that as being like our onions and garlic, our cauliflower, as being a lot of those white type foods. Now go ahead and go cook one of those white type foods in like a baking soda solution. What color do they normally turn? Well, what happens with anthoxanthins is they actually turn a yellowish color whenever we cook them in a base. So onions and cauliflower, they will do this. Whenever we add a base to them or any type of alkaline solution, they're going to change to kind of a yellowish color, whereas acid, they don't really change much at all. The next one is anthocyanins. To help you remember what an anthocyanin is, you just need to think of the word cyanin and cyan. What does cyan correspond to? Well, we think of cyan blue, like the blue sky, and that's what anthocyanins are. So that's going to be things like our blueberries and our red cabbage. Maybe in your food service class or in a lab, you actually did this red cabbage test at some point. Try to remember what kind of happened in that lab and how the red cabbage changed. When we add an acid to that red cabbage, the anthocyanins actually turn this very bright and vibrant red color. They actually turn more red in that case. Whereas when I was to add a baking soda solution or any type of alkaline solution, it actually turned into a deeper blue. So with anthocyanins, you can think of as blue as base and kind of think of that BB, putting those together to think about how those will change. Now let's give you a few practice questions to really try to hone these in and get better in this way. Which of the following foods will not react in an acid or base solution? A, broccoli, B, red cabbage, C, onions, or D, tomatoes. Again, which of the following will not react in an acid or base solution? So when I write out on my whiteboard or in my scratch paper, I'm going to write my A, B, C, and D. That way I can eliminate what my bad answers are in this case. What do we know about broccoli? Broccoli we can think of as our chlorophyll. And we know that chlorophyll, whenever we add an acid or a base, an acid it's going to change into that pheophytin olive brown color, right? When we added a base, it turned into chlorophyllin or chillin' like a villain, bright green. I'm going to rule out A because I just think it's a bad fit in this case. B, red cabbage. Red cabbage, we just talked about the anthocyanins. When we added an acid, it became more of a bright red, vibrant red color. Whereas when I added a base, B, blue, it turned into a bluish color in that case. C was onions, and onions corresponded to those anthocyanthins, or that whitish color. Now, it wasn't very reactive in an acid, but it was reactive in a base, turning more of a yellowish type color. So I'm going to rule that one out too. Let's double check our last one, which is tomatoes. That corresponds to that subclass of lycopene. And let me tell you, when you cook tomatoes down or make tomato sauce, turns out they still stay pretty red during that whole process. So tomatoes are going to be my best option, as those will not react in a state of a base or an acid state. Number 2, when overcooked or exposed to an acid, chlorophyll will change to a blank color. All right, so we're thinking in an acid with chlorophyll. So let's look at these here. A, bright green. B, olive brown. C, no change. Or D, blue. I write my A, B, C's, and D's here just to get those down. Bright green. Was bright green, did that correspond to the pheophytin, which is fighting off that acid or fighting off that base? Or did it correspond to the chlorophyllin? Well, if you remember, I said chlorophyllin's like someone who's dressing like a pimp, right? So they're dressed all in these bright, bright, bright green suits. So I'm going to go ahead and rule that one out because I know that bright green corresponds to chlorophyllin, and that's actually in the state of a base. B is olive brown. Olive brown I knew was pheophytin, and pheophytin is fighting off that acid and fighting off that heat. So I'm going to hold on to that. I think that's a good fit. C, no change. Well, we know that there is some change with chlorophyll, so I'm definitely going to rule that one out. And lastly, with D, blue. Is chlorophyll ever going to change to blue? Not that I know of and not that I've ever seen. So I'm going to rule that out too. Leaving my best answers was going to be my bright green or my olive brown. And then I know that acid would correspond to the olive brown in this case. Number 3, white plant pigments found in onions and garlic will correspond to the plant pigment blank. We have A, anthocyanins. B, xanthophylls. C, anthoxanthins. Or D, flavonoids. So what's going on with these ones here? I write my A, B, C's, and D's so I can eliminate what's going to be best or not. And I'm looking for the white plant pigments of onions and garlic in this case. Anthocyanins. Well, I think of cyan and cyan blue. So that's definitely not going to be my white foods. I'm going to rule that out. They are in the same class here, but I'm going to go ahead and get rid of them here. B, xanthophylls. Okay, the X kind of throws me off because remember I talked about the X does correspond to like the lack of white or lack of color in that case. But turns out that xanthophylls, remember, that's going to be the yellows in that case. So yellows is what I'm going to get rid of there. C, anthoxanthins. I do think that that's a good fit, as I do think that corresponds to white. Or D, flavonoids. Now, what you have to decide between these two answers is that flavonoids, anthoxanthins, for example, is those white type foods, and that is a type of flavonoid. But in this question, I'm asking specific to just the whites here, not flavonoids in general, like the blue or the anthocyanins. So I'm going to go ahead and rule out flavonoids here, which is going to make anthoxanthins my absolutely best fit in this case. That'll correspond to my white cauliflower, onions, garlic type foods. Today on the What's Eating You segment, I want to discuss a food sample that I handed out this week at the Cancer Center. I actually had a pretty down week for once in my life, so I felt like, hey, I've got plenty of time to try some samples. Went out to Walmart, decided to pick up some groceries and things to kind of run through and do some food samples with. So this week I thought I'd stick to that kind of fall type of setting. And I decided that I would go ahead and make some pumpkin pie smoothies, or a pumpkin pie shake as I kind of called it too. When I make these types of shakes, I need to make sure that they are 1, high calorie, and 2, high protein. It's the most important thing for my patients because we have to really focus on weight maintenance with them. So if I'm going to make a smoothie or a shake, I'm going to make sure it's high calorie and high protein in some way. With this high calorie, high protein pumpkin pie smoothie, I was able to get it up to 430 calories per serving and 35 grams of protein as well, which is pretty decent as far as when it comes to the shakes here. I started with, of course, my base, as I always do with my shakes. I went with 1 cup of cow's milk, but you could easily use anything like a soy milk or another plant-based milk, but I wanted to choose the one that would be highest in nutrients, highest in protein. Cow's milk would certainly be the best fit there compared to the others. Soy milk would be my other preference there, compared to like almond milk, cashew milk, because those are usually a little bit lower in calories and lack a lot of the protein we need. Then I went and added a nice medium-sized banana. The banana is the best part of this because it's really going to be what provides that sweetness factor of like a pumpkin pie taste. I know that sounds strange, but we need to get some sweetness added to this, and it helps out with the thick texture of it. Then I bought a $2 can of canned pumpkin that we would normally use for pumpkin pie, and I had about a half cup of that, although I could have gone up to about 3/4 cup if I wanted to really make it that orange and pumpkin type thing, but it helped out to provide some nice flavor, some nice texture, as well as it provided a great source of vitamin A and our carotenoids, right? My protein source came from 1 serving of vanilla whey protein powder that I had. This was 25 grams of protein per scoop, and I finally topped it off with 2 teaspoons of pumpkin pie spice to really add that extra flavor. And it was pretty good, let me tell you. People really did appreciate it, loved that it was on with the fall flavors. I think a lot of people did, not a lot of people, but a couple people were asking, hey, how can we get some more flavor into it? I always find that if I'm trying to avoid putting a lot of added sugars in there, I'm going to have to hold off in some way. And so I think some people's taste buds are just a lot more acclimated to a lot sweeter stuff or diet sodas, intense sweetness. And so some people will think, hey, I want it sweeter all the time. I know like whenever I make cookies or something for my grandma, she's always like, oh, it needs more sweetness. But truly it's like, no, I don't think it's that. I think it's just because you're much more acclimated to sweet things. So if you try to tailor those back a little bit, things like this that I make will taste a normal amount of sweetness. So that was a well-appreciated shake, and I had a great time doing it. But that ties it up for the Diet NPO podcast today. I hope you learned a lot about your pumpkin carotenoids, your plant pigments. Maybe you enjoyed some of my stories. Continue to rate and review the podcast. I've really appreciated everyone doing that. Check out my previous recordings if you want to continue learning more about the RD exam. Check me out on Instagram, Zak_snacks, or DM me if you have some RD exam tutoring needs. And hey, have a great day.